And the blue button means we're live. We will be going live. Give it a second here, make sure we're good with the seventh grade portion of the proceedings. Hope everyone's doing good. Those seventhers that are joining me here, I hope everything is going well. Hope everything is going well. And just to kind of remind y'all, the part where I talked about last Monday about the whole about that whole the video and all that kind of weird stuff there. Yeah, that supposedly there was some waltz that was within that video that caused a copyright claim against the channel. So yeah, we're not doing that there. So what's up? What's up, Narelle? What's up? How you guys doing? How you guys doing? We'll get started here in a little bit. Talk a little bit about percents. Hopefully I can make a little sense over YouTube here to kind of just give a little bit of a review to kind of get a little refresh the mind a little bit. You know, nothing too crazy. What's up, Katana? How are you doing? How are you doing? How's it going? How's it going? Give a second for the, as I said, for the sixth grade, the bat symbol to go up there and make sure we're all kind of, you know, kind of getting going here. Make sure we're all good. I think we got sound, right? Yeah, there we go. There we go. So what I'm talking about, what I'm going to talk about, what's this crazy guy going to talk about here? This crazy guy is going to talk about, going to talk about a little bit about percents. So a little bit about percents here. Percents, we're all going to be talking about percents, All right. So, what's up? What's up, everybody? Yes, yes. I guess some of you guys probably haven't seen each other in a while here. Pause that. No way. All right. Let's see. So the whole idea of this is we're going to be using what we call equivalent ratios to solve this. What am I talking about? Equivalent ratios to solve problems with percent. Equivalent ratios to solve problems involving percent. And this kind of leads into our little equation of part equals percent times whole. You guys remember that? Okay, so let me try to break this down. And just you can, in this instance, let's just start with this. Start with the example here. So we have Diego. So good old Diego. Good old Diego starts a 12-hour road trip with his phone's battery charge at 75%. Now, given his normal usage, will his phone last the whole trip? So will it last the whole trip on this? Now, what we can do on this is we can set up two equivalent ratios here. We can set up two equivalent ratios. And if you guys remember setting this up at one point during the year, I did talk about this during the year, but it's okay. The idea is to kind of get refreshed with this. So what do you see as your information? You see battery charge, and you also see hours left, hours that represents this. Okay. If I were to set up on one side of my equivalent ratios here, I want to set up a ratio on the left side first. The left side, I want to keep our information such as the battery charge. So if I said on one side, I want to keep 75%, and I'm kind of put this in a box for a reason, over 100% over here. We're going to be keeping on the left side the percentages each part of our little scenario here represents. Okay. On the right side, what do you not know? What do you not know? How many hours left? You're trying to find out how much does a 75% battery charge give you? Will give you. Okay. So the question on this is you're going to be setting on one side, like we talked about, are the percentages. So 75% over 100% on the right side. Okay. Even though these are set as fractions, you want to keep your information set on the numerator and the denominator. So the part where it says, and let me change this here to kind of prove, like to show my point. I'm going to box this in blue. If I box this in blue here, my 100% gives me how many hours? As how many hours? What's up, Nick? How you doing, man? Our 100% is going to give us how many hours? It's 15, right? So the 15 is going to stay over here, down at the bottom in the denominator. Now, what I want to do is I want to write the hours, but just to show the difference here, I want to put that in kind of like a box. Okay. So the 15 will stay in the denominator. Here's the thing. Do you know, and I'm going to change it one more time to show my difference here. Out of that 75% charge, do you know how many hours are left? No. That's going to give you what we call our little variable. That's the variable we're trying to find. We're trying to find, well, if 15 hours, so if 15 hours, if 100% charge gives you 15 hours, well, what does a 75% charge give you? This is what we're doing, is we're setting up our two equivalent ratios on, you're looking at me, on your left and the right. But you're keeping, in this instance, the hours on the same side, and you're keeping the percentages on the same side. You're keeping these things kind of, in the same part right there. So in this instance, we can then cross multiply and divide. We can cross multiply and divide. That's the way I would do it. That's the way I would do this. Okay. Let me get some, so it's not taking up the whole part here. If I take this down, there we go. So if I take 75 times 15, it's going to give me 1125, right? So it's going to give me 1125 if I'm, cross multiplying here. 75 times 15 is going to give me 1125. And the reason why I have those, like the hours and the percentages in boxes, because it technically doesn't matter for this, but I just want to show you how keeping those in the same, side, in the same ratio will help to kind of further understand this. So 100 times x is going to be 100x. If I divide by 100 on this, the 100s cancel. The amount of hours that is left, if I take 1125 and divide by 100, that's going to tell me that I have 11.25 hours. A 75% charge, in this instance here, in this specific example, means that I have an 11.25 hours left of that. I hope that's making sense. I know we're on YouTube, so it's kind of a little bit different, but you're keeping your percentages on one side, you're keeping your hours on the other, but then you're cross multiplying. But like I said, you're trying to keep the categories kind of the same here. So when you do that, you find out that X is going to be 11.25 hours. Yeah. I mean, kind of, Narelle. I mean, it really is. It's kind of, you're finding what this X is, and I know I'm drawing a bunch on this, but you're trying to find what that X is. You're cross multiplying, and then you're just using your order of operations here to find what X is. In this instance, you're trying to find how many hours is left. So in this instance, X is 11.25 hours. So to go back to the initial question here, given his normal usage, will his phone last the whole trip? And the answer, and then the answer on that is no, it won't. It'll run out just before, about 45 minutes before he's supposed to get there. He'll have a dead battery. Sucks for him. Hope that kind of makes, yeah. Okay, cool, cool. Yeah, I mean, like I said, I mean, it's on like a YouTube thing. It's kind of hard to exhibit this because I mean, if we were in class, we are physically in class, it's, we'd actually have the board and have things and have questions and have time to like, one-on-one in groups and all that kind of stuff. So just trying to not totally overwhelm, but yet kind of just still give these kind of basic informations of things. So let me kind of continue a little bit here. Just a little bit. Okay. So now, so now here's another thing. Another way of setting up two equivalent ratios. Let's look at our little problem here. It says a full set of adult teeth. Nice picture. A full set of adult teeth includes 160% as many teeth as a full set of baby teeth. And obviously it tells you the answer here, but just to kind of break this down, it says how many teeth are there in a full set of adult teeth? So in a full set of adult teeth, in your instance right here, say you did not know this. Say you didn't see this. I know you can see this. Hey, if it makes kind of sense, if it makes somewhat sense, that's totally fine for the scenario we're in right now. So I'm cool with that. I'm cool with that. So I want to kind of just break it down to kind of because it gives you this information, which is totally fine, which is correct, but just to kind of give it in my spiel on this here. A full set of adult teeth includes 160% as many teeth as a full set of baby teeth. How many baby teeth are there? So there are 20 baby teeth. I'm going to call it BT. Okay, 20 BT. What are you trying to find in this question? Is how many teeth are there in a full set of adult teeth? Let's keep our teeth. Let's keep our teeth to one side of the equivalent ratio here. So in this instance, it would be X adult teeth. I hope my abbreviations make sense here. We don't know how many adult teeth in this specific example. The 20 baby teeth is 100%, 100% of what we're trying to figure out. The adult teeth are obviously more than 20, right? I mean, if you look at 160%, if you got 160% on a test, that means you got something like a 35 out of 25. You got a crazy amount of good amounts on that. All right, so that bottom part that you see right here, the adult teeth, that full set of adult teeth is 160% in this. And it works the same way. You then cross multiply, cross multiply. So 20 times 160, 20 times 160. There we go. I know I can do this in my head, but just 20 times 160 is going to be 3,200. So it's going to be 3,200. I'm just kind of moving up here. Is going to equal 100x, and then divide both sides by 100. When we divide both sides by 100, it's going to be, and as we see, it's going to be 32. It's going to be 32. There we go. Obviously, if I take 3,200 divided by 100, it's going to give me 32. 32. And 32 is equaling our adult teeth. And what do we have right here? 32 equaling t. Again, it's how you want to determine that, but like in this instance, that's what I would think would be kind of a good way of doing this. And it's, that's setting up two equivalent ratios to be able to find something in relation to percent. Okay. Again, you're just getting somewhat sense on this. That's good. I mean, that's good. Again, we're over YouTube, so it's a little, like I said, it's a little different. Okay. All right. Forward just a little bit, and I'll answer those questions. So here's a good one. So here's a good one right here. So if you can see in our little information that we're given here, if, from the Earth to the Sun is 93 million miles. It's 93 million miles. And the distance from the Moon to the Earth is 0.27% of the distance between the Sun and the Earth. So between the Sun and the Earth. It says, well, what is the approximate distance in miles from Earth to the Moon? Okay, so now we have a little bit of room here. I'm comparing distance to the percent, right? We're trying to find distance. So on my left side, I know that from Earth to the Sun, it's 93 million miles. So 93 million, 93 million miles from the Earth to the Sun. Do we know the distance between the Moon and the Earth? We know a percent, but we don't know the actual physical distance. That's what we're trying to find out in this instance here. So this distance from the Moon to the Earth is going to be x. We don't know that yet. Okay. Let's set it now to our right side. The 93 million miles is our 100% of our comparison, right? Earth to the Sun is 100%, because our percent for the Moon is being in comparison to the Sun and the Earth as well. So we're keeping our categories. We're lining them up here. We're lining them up like you see. So on the numerator of this ratio here, it's going to be 0.27, because it's a very small percent, right? It's a very small percent. It's a very small percent. And again, it works the same way. You cross multiply. So x times 100 is 100x. And just for the sake of this, take your 93 times your 0.27. Basically what you're saying here is, what's 0.27% of 93 million? What's 0.23 or 0.27% of 93 million? And like we had just saw right there, 93% of that. 93%, what am I talking about? Got one more. Ah, goodness. There we go. There we go. There we go. There we go. Remember, when you're doing this, that 0.27 is represented as a percent. So one more time. Sorry, guys. It's going to give you that, and then divide it by your 100. Sorry, missing a step right there. When you cross multiply and divide, your x is going to be 251,000. What I did is I took x times 100, and then I took 93 million times 0.27. Yeah, Nathaniel. Yeah, exactly. Exactly. That's exactly it. You can take 93 million times 0.27. It's the same thing. I'm just showing it as a way of dealing with equivalent ratios. Both ways work with that. That's actually proceeding further. Like the next part is then actually being able to show doing that part. Doing part equals percent times whole. And so if the whole distance in this is your 93 million miles, you're trying to find what the part is. What we're trying to what we're trying to show in this is we're trying to show that show how equivalent ratios lead into doing the part equals percent times whole. So yeah, perfect. It's a perfect thought process on that. It's exactly it. It's exactly it, man. Yeah, Nora, that is a long walk, Nora. Oh man, yeah, that's 251,000 miles. I mean, that's what it is. That's what it is. Okay. So in this instance, I'm going to move to the questions real quick to finish like this part 3.1 right here. Again, just showing it in like a proportion way of doing things in this. So if I were to say, well, find 0.8% of 1046, if I were to set this up, as two equivalent ratios, 0.8 over 100 is 1046. X over 1046. You can cross multiply and divide, or in this instance, the way that they show this here too, is you can actually sit there and then take 0.008 times 1046, which will give you about 8.68, I believe, is what that is. Tell me if I did that there. You said, yeah, I moved into the questions there. So if you have those with you, bring them out. If you don't, that's okay too. Just I'll be done here in a few minutes. I lost my page here. Sorry, guys. Yeah, there we go. But yeah, it's the whole idea. The whole idea of this is to kind of show that, well, you can set up two equivalent ratios to find your answer, or you can use the equation as well too. 0.8 times 1046 will give you what you have. Let me bring this up. It matters what makes it easier, you know. It matters what makes it easier. If I take 0.8 times 1046 and it's 836.8. So if it's 836.8, 836.8 equals 100x, and I divide both sides by 100, and I divide both sides by 100. If I divide this by 100, it'll give me 8.368, like we were saying, okay? 8.368. 368 is going to be your answer, right? All right. And then you can go into the next one. You can say, well, what's 160% of 98? 160% of 98. If you wanted to do it the other way, if you were trying to find, well, you're trying to find, if I were to go part, remember part equals percent times whole. That's the other way of doing it here. Part, we don't know, equals the percent of 160% times the, make a lighter thing so you can see it here. There we go. Times the whole of 98. Remember, when we're multiplying a percent times something, this has to be changed to a decimal, so it's 1.6 times 98. 1.6 times 98 is going to be 156.8. 156.8. Equal part, and 156.8. Which would make sense. 156.8 is bigger than 98, right? 156.8 is bigger than 90. All right. And last one here. Break this down here. So a company charges a shipping fee that is 4.5% of the purchase price for all items it ships. What is the fee to ship an item that costs $56? So what is the fee? Now, this would be where setting up like the ratios, the equivalent ratios, probably be easier to do it. I mean, it's up to how you can visually see things. I mean, some people like to see things visually with the two ratios. Some people can do the part equals percent times whole. It definitely just depends on what's your personal preference on this. Now, in this instance, the company charges a shipping fee that is 4.5% 4.5% of the purchase price. So 4.5% of the purchase price. So what would be our 100% purchase price? Well, it would be $56, right? It'd be $56. Put the dollar sign kind of over here. Okay. What we don't know what the fee is, right? We don't know what the fee is. So if we were to, again, cross multiply and divide, if I take 4.5 times 56, it's going to give me my 252. My 252 is going to equal my 100x. And if I divide both sides by 100 in this, 252 divided by my 100 is going to be my 2. So the fee that is going to be charged in this specific word problem is going to be 252. Guys, I hope this makes sense. If you have any, we'll talk more about percents and percent markups, percent markdowns, and all that kind of good stuff here tomorrow. For those of you who be live with me or on demand, I thank you for those of you who joined me here live, getting up here in the morning. I know it's sometimes it's difficult, but I hope you all are doing good. Guys, stay safe. Have a good day, and I'll talk to you guys later.